Hey everyone, Mr. Voikin here, and it is time to review for the year-end summative test. We're going to start with Unit 1 and looking at percentages, fractions, and decimals. So question number 1, convert 0.85 to a percentage. So this is quite easy. All you're really doing is just taking the number 0.85 and multiplying it by 100. And that will give you 85. And because we're changing it to percent, don't forget to put the units of percentage right there. So what are we doing? Well, when we're changing from decimal to percent, we're actually taking that decimal that is right here, and we're just jumping it 2 spots, and you can see where it ends up on the other side of the 5, which is going to give us that answer again of 85%. Okay, how about converting a decimal to a fraction? Well, when we take a decimal, it is going to be 0.18, and you can see with the 0, we have 1 digit, 2 digits, and 3 digits. So what we want to do is put that over that number 18 over a number 100, which also has 1, 2, 3 digits. Okay, so now all we need to do is start to simplify this fraction. So I can see that 2 can divide into the top and 2 can divide into the bottom. 18 divided by 2 gives us 9, and 100 by 2 gives us 50. So the only number that can divide into 9 is 3 and 9, and I can see that 3 and 9 cannot divide into 50. So our final answer is going to be 9 over 50. All right, number 3, converting a fraction to a decimal. So when we're converting a fraction like 7 over 8 into a decimal, what we need to do is divide the bottom number into the top number. So 8 needs to go into 7. Now don't forget that we have that decimal place right there, and the best thing to do is just take that right up to the top, right there. And now we can add as many zeros as necessary behind the decimal. It doesn't change the number. Now I ask myself, does 8 divide into 7? Well, the answer is no, so we're going to put a 0 there. Now, does 8 divide into 70? Can 8 go into 70? Yes, it can. Well, how many times? Well, 8 times 8 is 64, so it goes in there 8 times. I put a 64 right there. Subtract this, and I'm left with 60. Now I'm asking myself, does 8 divide into 60? Well, yes, it does. It goes in there 7 times. 7 times 8 is 56, so it goes in there 7 times. And if I subtract this again, I've got 4. And like I did right here, when I brought down that 0, I need to bring down this next 0. So this becomes 40. And finally, I'm going to ask myself, does 8 divide into 40? And of course, the answer is yes, because 8 times 5 is 40, and 40 minus 40 is 0, so we are done. At this point, we just need to take this number and lay it out. My final answer is 0.875. Okay, moving on to question 4, convert a fraction into a percentage. Well, this one is going to be 2 steps. So we have 2 steps. First, we need to go from a fraction to a decimal, and then from a decimal to a percentage. Okay, so we're going to do the fraction to decimal just like we did in question 3, where I have 3 over 8. So what am I going to do? I'm going to divide the 8 into the 3. Okay, so 8 divides into 3. Again, put that decimal there, bring it up to the top, add some zeros. Does 8 go into 3? No. Does 8 go into 30? Yes, it goes in there 3 times. 8 times 3 is 24. 30 minus 24 is 6. Bring down that 0. We got 60. Does 8 go into 60? Yes, it does. It goes in there 7 times. 7 times 8 is 56. And we need to subtract that again. So 60 minus 56 gives us 4. Bring down that 0. We have 40, and again, 8 times 5 is 40, and when we subtract, we're finished. So our decimal value is 0.375, and remember what we're doing to convert from a decimal to a percentage, which is where we want our final answer to end up as a percentage. What am I doing? Well, I'm taking that decimal right there and I'm moving it, whoops, let's grab just the decimal, 2 spots, just like that. Okay, so what is our final answer? Our final answer is going to be 30. Let's try that again with red, 37.5, and don't forget percent. Okay, so converting a percentage to a fraction. Okay, so again, we have 55%. And what we want to do is take any percentage. A percentage is out of 100. So this is 55 of the 100. So we would write this like this. This is 55 of the 100. Now what do I do again? I need to reduce this fraction down to its simplest terms. So this is a fraction, but again, it's not in its simplest terms. So I can see 2 cannot go in there because 55 is not even, but 55 ends in a 5, 100 ends in a 0, so 5 can be divided into both of those. So 55 divided by 5 gives us 11, and 100 divided by 5 gives us 20. And the only number that can divide into 11 is itself, and 11 cannot divide into 20, so we are finished, and the final answer is 11 over 20. All right, question 6, percentage to a decimal. And on this one, try to remember that when we went from decimal to percentage, we moved that decimal 2 spots to the right. So we're going to do the opposite when we're going the other way, and we're going to move it 2 spots to the left. So we look at the number 4%. Well, where is that decimal? It is right there. So what we're going to do is we're going to literally jump that 1 spot and then 2 spots. And so the decimal now ends up right there. But I need to fill in these empty spots. So between the decimal and the 4, there's an empty spot. So we'll put a 0 there. And we always put a 0 in front of that decimal. So our final answer is going to be 0.04. And just to double check that, again, remember, what can we do? Well, if I was going from 0.4 or 0.04 to a percentage, I would move it 1 spot, 2 spots, and we end up with 4%. Verified. Okay, question number 7. What is 20% of 1,600 meters? So it's not all of it. It's not 100%. It's only 20% of the 1,600. So the final answer should be smaller, less than 1,600. This word right here, of, is quite important. That usually means time. So usually means time. So now remember, 20% is not a number that we can use in our calculations. We need to change that to a decimal. So how do we go from a percentage to a decimal? Well, remember, the decimal is right there at the end of the 20. So what do? We move it 2 spots to the left. 1, 2. So I have a decimal value of 0.20. And I'm going to multiply that by 1,600. So if you're using a calculator, you'll just punch the numbers in. If you're doing multiplication by hand, you may have to do that calculation off to the side. And remember, that decimal right there is going to be important in the final answer. So let's just do that together. 1,600 times 0.2. Now you don't have to worry about that last zero there, it's insignificant. Now if I was to multiply this through, 2 times 0 is 0, then 0, 2 times 6 is 12, carry that 1, 2 times 1 is 2, plus that 1 is 3, and our answer is going to be 3,200. But because I have one decimal place right here, I need to also have one decimal place in my answer, so that decimal is going to go right there. So this equals 320. So 320 is 20% of 1,600 meters. So if we're talking about meters right here, then I also need to have meters in my final answer. Okay, question number 8 says 300 feet is what percent of 10,000 feet? So this question is worded sort of backwards, but it still makes sense. But let's take a look at this portion right here. What percent of 10,000 feet? And really I can now say is 300 feet. So I can move that to the back side. It sounds a little bit better. Okay, so what about these words right here? Well, remember what of is? It's times. And what about the word is? Well, is usually refers to equals. So I put that number in there, 10,000, and this number here, 300. And when it says what percent, that's going to be a variable. So some number right there. So what times 10,000 will equal 300. Okay, now with algebra, we're better off writing this as 10,000. X is our variable equals 300. And we know with our algebra, to isolate that X, I need to get rid of the 10,000 on the left side. And to do that, I'm going to divide by 10,000. Whatever I do on the left, I do on the right. It cancels here on the left, and I'm left with X equals 300 divided by 10,000. Now, when you get two large numbers like this with all these trailing zeros after the initial digit there, I can just start canceling them as long as I take one from one and one from the other. So get rid of 1 0, get rid of 1 0 on the bottom. Get rid of that 0, get rid of another 0 on the bottom. So now what we're down to is 3 over 100. And you know that percentage is out of 100. So 3 of 100 is equal to 3%. And that is what they're asking for. What percent? So this equals 3%. So our answer is 300 feet is 3% of 10,000 feet. Okay, question 9. We're now into some word problems, and this one confuses a lot of people because we're going to have to generate a number from the numbers that are there to use in our calculation. So let's take a look at what it says. We got a shoe store. It doesn't really matter what the store is or what they're selling. We know that we have an object that is starting at $250 and it decreases. So it says it decreases, which means it goes down, and its final price is $175. So it started at $250, and after they lowered the price, it is now a little bit cheaper at $175. What do they want us to calculate? The percentage of decrease. So how much did it go down? Well, think about how many dollars it went down. It went down from 250 to 175. So if I take 250 and subtract 175, it went down $75. So what percent did it go down? Well, it started at 250, so 75 is what percent of 250? Okay, so that's how much it went down. It went down 75 of the 250. Okay, and I can just set it up exactly like this. Once I get proficient with understanding how to set these up, it becomes a lot easier. And now, again, if I have a calculator, I'm just going to punch that into the calculator, and if not, I'm going to have to reduce this fraction down to simplest terms and then do some division. Okay, so 75 divided by 5 is going to be 15. And if I look at 250 divided by 5, we have 50. So I'm down to 15 over 50. Now, this is sort of a good number to end up at here, because remember, percentage is out of 100. So really, if it's out of 50, I could just multiply this by 2 on top and bottom, and now I'm going to end up with 30 out of 100. And what do I know about any number out of 100? That is the percentage. So 30 out of 100 is 30%. So a word problem says, what is the percent decrease? The shoes decreased by 30%. Okay, question 10 is very similar to the last one, question 9, except in this case we can see that we're looking for a percentage increase. So it went up. So the word that signifies that is they raised the cost of the bread. So where did it start off? It started off at $3.25, and where did it end up? At $4.50. So just like we did last time, we say it started off at $3.25, it went up, and we end up at $4.50. So how much did it go up? In dollar values, it's 4.50 minus the 3.25. When I subtract those, I'm going to get 1.25. So it went up $1.25. But we want to know what percent it went up. So what we have to do is say 1.25 is what percent of the 3.25. So how much of the 3.25 did it go up? It went up 1.25. And if I put that into a fraction form, I can then change it to a decimal and finally to a percent. Now here's another trick you can do right here. We have that decimal in there. It looks like it could be some complex math, but I can basically move this decimal to the right 2 spots. That's by multiplying by 100. 1, 2, as long as I do that on the bottom. So what I end up with now is 125 over 325. We've essentially eliminated that decimal. Okay, so now I see it ends in 5 on both of these, so I can divide both of those by 5. So 125 divided by 5 is going to be 25, and 325 divided by 5 is going to be 65. Again, I can see they both end in 5, so I can divide by 5 again. 25 divided by 5 is 5, and 65 divided by 5 is going to be 13. So now we're down to a more manageable fraction of 5 over 13. But what are we trying to do? We're trying to get to a percent. So what do I want to do? Divide the bottom number into the top number. So 13 goes into 5, add that decimal, bring it up, toss on some zeros. Does 13 go into 5? No. Does 13 go into 50? Well, yes it does. How many times? Well, 13 times 3 is 39, and 13 times 4 is going to be, let's try that out, 52. So 4 is a little bit too much, so we're going to go with 3, which is 39. Subtract that, and we end up with 11. Okay, well, 13 can't go into 11, so bring down a 0, and we have 110. So 13 times 8 is going to be 104. So it's going to go in there 8 times. We got a 104, and when I subtract that, I'm left with 6. Again, I can bring down that 0 like I did before, and I now have 60. How many times can 13 go into 60? Well, that's the 4 times, which is going to give us 52. And again, I need to subtract that, and I'm left with 80. Okay, so 13 times 6 is going to be 78. Okay, so I'm going to put a 6 right there, a 78, and we're left with 2. At that point, I can probably stop. Okay, so what are we trying to figure out? A percentage. We have a decimal now that is 0.3846. We sort of went way too far. Probably could have stopped at that 4. Now, it depends where they're asking you to round this. Okay, so remember, I'm going to move this decimal 2 spots, and what I end up with is 38.46%. Now, if I was going to round that to 1 decimal, it would be 38.5%. If I was going to round that to the nearest whole number, it's going to be 39%. So let's say we're rounding it to the nearest whole number. What is my final answer? The cost of the bread increased by 39%. Okay, last 2 questions in this review. Number 11, a factory worker makes some widgets. How many does he make? He makes 480 widgets. How long does it take him to do that? 8 hours. So it says, what is his rate of making widgets? Now, anytime we're talking about a rate, we want it like sort of as a per hour. So an example of a rate would be speed. I'm driving 30 kilometers per hour. We don't say I'm driving 60 kilometers per 2 hours. Okay, so if I'm making money, I get paid a salary of $22 per hour. Okay, now what we want to find out is how many widgets does this factory maker make per hour. Okay, so we know that he makes 480 widgets per 8 hours. So what I want to do is create an equivalent fraction and set it up as a 1 hour. So how much does that worker make in 1 hour? Now, all I'm really doing is just dividing the bottom number into the top number. Now, if I set it up like this, which is very useful, we're doing some cross multiplication and then moving into algebra. But again, the simplest way to do it is just divide the bottom number into this top number right there, and that will give you a per hour number. But if I'm cross multiplying, I'm going to do this. 8 times x gives us 8x equals, and I cross the other way, 480 times 1 is 480. And now when I divide by 8 on the left and divide by 8 on the right and cancel, I'm down to x equals 480 divided by 8, which is exactly what we said to do right here. Okay, so if we divide 480 by 8, we end up with 60. Okay, so this equals 60, and the final answer would be the factory workers' rate of widget making is 60 widgets per hour. Okay, here we go. One more question. Okay, now in the last question, remember we had this word right here, which is rate. Okay, well, in this question, we're looking at a ratio. A rate always ends up as a per one. Okay, so like we had 60 widgets per 1 hour. With a ratio, we're just basically taking a fraction and simplifying it down as far as it can go. Now, in this case, we're looking at 45 girls and 20 boys. Okay, so you want to set it up as a fraction. So 45 girls and 20 boys. We want to end up with a ratio of girls to boys. So how many girls for every, and how many boys are there that make up this ratio? So I can see that 5 can divide into 45, and we end up with 9. And 5 can divide into 20, and we end up with 4. So we have 4 girls per 4 boys. And as a ratio, it's usually written like this, 9 to 4. And as a word problem, we would answer this as the ratio of girls to boys is 9 to 4. And what's important to note here is that it states that there are girls to boys. So in our number, our ratio, it needs to follow that pattern. Girls to boys. Okay, we're done.